Okay, volumes of prisms and cylinders. The volume of a solid is the amount of space it occupies. Now when it comes to volume, it's a 3D, okay? 2D is mainly for areas and 3D is for volume because you have to contain something inside, okay? So volume is measured in cubic units. So it could be meter, cubic meters, cubic centimeters, or cubic millimeters, whereas the area was squared, okay? Now let's have a look at a summary of the formula of these two, prism and cylinder, okay? So try to memorize it. The basic concept here, principle here is volume is the area of base, the shape of the base, and times by height. Now cylinder is a little bit different because cylinder is not really prism because none of the side is a straight like a polygon, okay? So a cylinder has a little bit different formula, but concept of the area of the base times height is still applies here because base is a circle, so the area of the circle is pi r squared and the h is height, okay? So remember that doesn't change. Okay, so because we are doing some volumes, we need to think about the capacity of a container is the amount of fluid or liquid or gas and it holds. So measured in the milliliter, liter, kiloliter, and megaliter liters. So now this you need to memorize. 1 cubic centimeters equals 1 liter. 1 cubic meters equals 1,000 liter, which is equal to 1 kiloliter. Now easiest way you can remember this is something like this. I think you've probably done this with the centimeters, meters, and kilometers and all that sort of thing as well. So remember, only different thing is that each time it changed the unit is a times by 1,000, or getting smaller will be divided by 1,000. Okay, so we've done all the prep. Now we're going to do the question. So here is the first question, guys. For this cylinder, calculate A, its volume, correct to the nearest cubic centimeters, and B, its capacity in kiloliter, correct to 1 decimal place. Okay, so let's have a look at this. Now, to find the volume, first thing you got to do is what? Volume of cylinder is a pi r squared times height, isn't it? Yeah, because the area of the base is a circle, which is pi r squared. Now, what is r? What is h here? Before we can take it on the question, it's like a cooking, guys. As I mentioned before, you need to prep with your ingredients first before you actually do the cooking part. So that's what we're preparing this. Radius, that's a diameter, 128. So radius is a half of 128, which is 64. It's a centimeters. I'm just going to put centimeters there. Height is on the side here, 241 centimeters. So I've got now volume equals pi times 64 squared times 241. I like to put that in brackets so I can see clearly which parts I'm timesing it. And if you put all that in your calculator, you'll get quite a big number, 3,101,179.206. But what does the question say up there? To the nearest cubic centimeters. So I'm going to go like this, cubic centimeters. There you go, that's my answer for it. Now I'm going to change the color. Now, this time it's the capacity in kiloliter. Now, remember this, guys. I'm going to just memorize that diagram here. So if I jump it here, I have to times by 1,000. I'm going to push up a little. Times 1,000, go back, divided by. So what are we looking at? We're going from cubic centimeters to kiloliter. Now, there has to be something happening here. We need to translate this cubic centimeters into milliliter. Remember, we got 1 cubic centimeters equals 1 milliliter. So I'm going to change from milliliter to kiloliter. That's what I want. So here it is, milliliter to kiloliter. So I'm going to go from here to here, right there. So that means I'm going to divide by 1,000 twice. Okay? So from A, we got volume equals 3,101,179 milliliter. And I'm going to divide it by 1,000 and then divide it by 1,000 again. And if you do that in your calculator, you will get 3.1 kiloliter. Okay, so that's done. Now, example question 2, I meant. Now, hopefully you can see this one a little bit clearly. So what I've got here is find the volume of each solid. So you got question 2 and 3, that we have to find the volume. So they're all the measurements in the centimeters. Let's have a look. So now I can see there's 2 solids here, sort of combined. One, I can see rectangular prism, and then I can see this triangular prism there. So if I have volume of a rectangular prism and take the volume of triangular prism, I will get the solid volume of this solid. Okay, so that's what I'm going to do exactly. So here we go. I'm going to just write it down here in a shorthand here. So volume is volume of rectangular prism take away volume of triangular prism, and that's the volume of the solid. Okay, that's what I'm going to do. So, well, volume of rectangular prism is quite easy. All you have to do, you just times all 3 numbers, because area of the rectangular prism is the rectangle, which is this on the bottom, and the height is 15. So I'm just going to times all 3 numbers. Done. And the triangular, remember, we are not looking for surface area, so you don't have to think too much about here. What's the base shape here? It's triangle. And luckily for us, it's right angle triangle, so you don't have to think about, you know, which one's the base, which one's height. Just 8 and 6 and halve it. Half times 8 times 6. Okay? And then the height of the triangular is this 25 here, times 25. Okay? And then when you do that, you will get 12,900 centimeters, cubic centimeters, because they're all measurements in centimeters. Okay, so that's done. Next one. I've got this one looks a little bit similar to the previous one, but it's not. It's a cylinder and taken out the part of the cylinder. Okay, so what I'm going to do here is the volume of the solid equals volume of the cylinder, the whole thing, okay, and then take away volume of part of cylinder, the cylinder. So this part, if I just take this one out, it looks like sort of, see if I can sketch something like that. It looks like this, guys, isn't it? It looks like that. So it's not triangular prism, it's actually part of cylinder. So that's about 100 degrees right there. It's not 90 degrees, so it's a cylinder with about 100 degrees. Okay, so what I'm going to do here is I'm going to go pi r squared. Okay, so pi r squared, so what's r here? It's 5 squared times height is 14, and then take away the part of the cylinder. So we still do the same. Pi times 5 squared times 14, the same. But this is not a full cylinder. So it's partially one. So it's 100 degrees out of the 360 is the part it's taken out. Okay? So if you do that and you use your calculator, put all that in. And then it says, I'm just going to write it in 2 decimal places. So 794.12 cubic centimeters. Okay, so remember to stick with the area of the base times height for your volume. Now, last question. Okay, you've got 2 parts in it. First part is, now this is what it calls the greenhouse. Okay, so we need to find the volume of this greenhouse, and then part B is apply question. Okay, so let's have a look. Same principle applies here. To find the volume of this greenhouse, I've got to find a volume of half of cylinder, because that's the half of that, plus this time, not take away, plus it because it's add on to it. And then the bottom part is what? Volume of the rectangular prism. I like rectangular prism. I think it's easiest solid to do. Okay, so half of it. So I'm going to halve the volume of the cylinder. Pi r squared. What is r here? That's a diameter here, guys. And that's a 4. So what is half of 4? 2. So I'm going to go pi times 2 squared times the height is this, which is 10. Plus, now rectangular, easy. 3 times 4 times 10, just times all 3 numbers. And if you put that in your calculator, you will get 182.83 meters cube, sorry. So, and then because it's 2 decimal places. So I've got that and done. Just underline that. Now, next one, it says, if this greenhouse costs 0.5 cents per cubic meter per hour to hit, how much is this per day? Correct to the nearest cent. Now, nearest cent is 2 decimal place, okay? So let's have a look at this, guys. Now, first thing first, 0.5 cents is not really it's a 5 cents, okay? So you've got to do 0.5 divided by 100. You will get 0.005, okay? So that's first thing you got to do. So each 1 cubic meter is going to cost this much. So I'm going to change it to red, 0.005 times how many cubic meters we have? Up here, we're going to use what we got from the part A. So I'm going to go 182.83 times how many hours per day? 24 hours. So if you put all that in your calculator, you will get $21.94 per day. Okay, well done, people.